Thermoplastics first debuted in the 1930s when the first true thermoplastic was made by English scientist Alexander Parkes. The plastic could be colored and molded into whatever shape the owner demanded and was made by combining a cellulose nitrate with a solvent. Some of the first thermoplastics are listed below, with many popular ones being plexiglass, Parksine, and Bakelite. Nowadays, there are 7 different types of thermoplastics. You can figure out which type of thermoplastic you have by locating the triangle with the number in the center. The number indicates the identification code of the thermoplastic. Unfortunately, the United States only recycles 2 out of the 7 due to cost and logistical issues. The manufacturing process of the thermoplastics involved base raw materials of coal, natural gas, cellulose, and crude oil, with many thermoplastics including a polymer resin into the mixture as well. The crude oil, being a focal point of the mix, contains the carbon and hydrogen that are required to make the polymer chains of the thermoplastics. These materials are processed along with colorants and additives that depend on the specification of the finish. These materials are then blended together to form a homogeneous mix, which is then heated and rolled into whatever specified length and width. It is then cut into whatever desired shape and sent off into the world. We come into contact with many thermoplastics every day, with items such as water bottles to take-out food containers to personal food packaging. Thermoplastics tend to be more flexible and are often used for personal use and food items. With such turbulent times such as COVID-19, thermoplastics have had an increase of use for businesses and restaurants so that they can remain open with following safety protocols. So, why are they so recyclable? Well, as they say, beauty lies within, and this also applies to our thermoplastics. Thermoplastics have a linear molecular structure. This means that rather than catching on fire like thermosetting plastic would, thermoplastics deform and will melt. Continuing deeper into the structure of thermoplastics, we observe that before polymerization, the carbon chain has 2 covalent bonds, or a double bond, that involve 4 electrons rather than the typical 2. These extra 2 electrons allow for carbon bonds to be stronger and more resistant to breaking. This means that they can be melted down and recast into new products. This process has since been picked up by the internet, and since about 2015, videos and articles have been made showing the melting and molding processes of bottles and their caps. As time shows that society has started to grow a more eco-conscious mindset, and a demand for more environmentally safe protocols have been made. Artists such as Marcela Pedros have been using their work to raise awareness of the recyclability of thermoplastics by creating working furniture only with upcycled plastics that have been discarded as waste. Thermoplastics have made countless amounts of products in the world and have actually changed and revolutionized the world of materials. Its recyclability can help curb the growth of pollution and helps take plastics out of our world. This might just result in a little bit better of a world that we have.